Bismillahir Rahmanir Rahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Here, first of all, we are going to discuss that multiplication of a scalar with a matrix. Okay, as we told you that we are going to discuss the topic that multiplication of matrices. And here, first of all, we are going to discuss that how we can multiply a scalar with a matrix. So here I'm going to give you the example that if I am talking about scalars, that it means any number like 1, 2, 3, 4, any natural number or etc. etc. So that are called a scalar like this. If I am writing the 5 and I am writing a matrix like A, B, C, D. So here you can see that I'm going to multiply this matrix with 5. So obviously this 5 will multiply each and every element of this matrix. So its resulting matrix will be 5A, 5B, 5C, and 5D, and bracket close. Now you can observe that while writing a matrix, I am giving a sufficient gap between two elements. So it is very necessary to write like this. Remember this. So it is very simple to multiply a scalar with a matrix. So this is the method that how we are going to multiply the scalar with the matrix. Let us have another example. For example, if I have the number 7 uh, and I have a matrix like 3, 2, 8, 5. So the resulting matrix will be 21, 14, because 7 threes are 21, 7 twos are 14, 7 eights are 56, and 7 fives are 35. Let us have another example of this type. If I have, say, 1 or sorry, here you let me focus this page. Suppose I have 1 over 5 and I have 10, 25, 3, and like 8. Suppose these are the only examples which I am going to give you. Okay. So how I'm going to multiply this? You can see that 1 over 5 when multiplied by 10, your answer will be 2 because 5 twos are 10 and 5 fives are 25. Okay. Now here we cannot divide, so it will be 3 over 5. In the same way, it will be 8 over 5. So this is how we are going to multiply a scalar with the matrix. So if I'm talking about scalar, so the number which is written outside the matrix, that is called a scalar. Now this was very simple. Those who are coming late, they can watch the video on the Edmodo. So I am going forward the matrix by another matrix. It is very important to learn this topic actually, because sometimes students got confused about this. So that's why it is very important to see that what I am going to do. For example, I have a matrix like A, B, C, D. And I have another matrix like 6 and 7. Suppose these are two matrices. Now, first of all, before the multiplication, you have to observe one very important thing, that you have to observe the order of the matrices. In the case of addition or subtraction of the matrices, I told you that the order of the matrices must be the same. But here in this case of multiplication, what you have to observe. Now you can see that this is the first matrix, this is the second matrix. If I'm talking about uh, because you know that in English we read from left to right. So from left, this is the first matrix, this is the second matrix. So this matrix has the order. What is the order of this matrix? I'm mentioning the order of this matrix. This is 2 into 2 because 2 rows and 2 column. 2 into 2. Its order is 2 into 2 because there are 2 rows and there are 2 columns. In the same way, this matrix has 2 rows and 1 column. So this is 2 multiplied by 1. Now here you can see that the order of this matrix is 2 into 2 and the order of this matrix is 2 into 1. So whenever you are going to multiply two matrices, you have to see their order first of all. You have to see that this is a row and this is column. This is row and this is column. Okay, row multiply by column. So remember this, the column of the first matrix must be equal to the row of the second matrix. For the multiplication, you will have to observe that the column of the first matrix must be equal to the row of the second matrix. This must be remembered before multiplication. Okay, now let me have another example. I am writing another example like if I write A, B, C, D, E, F. Now here I am writing another matrix and I have another matrix like say 6 and 7, say the same matrix. Now here you can see that the order of what matrix, so there are 2 rows and 3 columns, 2 into 3, and here I have the matrix 2 rows and 1 column, 2 into 2 rows, 1 column and 1 column. Now you can see that this is row and this is column. This is row and this is column. Now here the column of the first matrix, the column of the first matrix is not equal to the row of the second matrix. So first of all, I'm telling you that you must observe this thing. This is a very important thing to understand, that here you can see that the column of the first matrix are equal to the row of the second matrix. These are equal. Column of first matrix is equal to the row of the second matrix. These are equal to each other. But here you can see that these are not equal. Not equal here. The column of first matrix is not equal to the row of the second matrix. First of all, you have to observe this. Okay. So if they are equal, then you can multiply. If they are not equal, then we cannot multiply. Look, I have a matrix like A, B, C, D. These are the 4 elements in this, and here another matrix in which I showed you 6 and 7. Well, now you can see, as I told you in the first case, that column of the first matrix must be equal to the row of the second. So here there are 2 columns and here there are 2 rows. These are 2 equal, so we can multiply. Now what we are going to do? You will have to keep it like this. I am mentioning, for example, this column is written like 6 and 7. This is written 6 and this is 7. I have made the entries of this column like this to show you. You can see that this is the column 6 and 7 of this second matrix. What you are going to do? You are going to multiply it like this. You are going to rotate it like this. The 6 will multiply with A and 7 will multiply with B. In this way, you will have to keep it like this. 6 will multiply with A, 7 will multiply with B. In the same way, keeping it like this, 6 multiplied by C and 7 multiplied by D. I am writing it again because it is very simple, a small page. So I am going to write it on another page to make more clear. This is 6 and 7 in this way. Now look here. This is 6 and 7. To make you more clear, 6 and 7 is written here. So you will have to rotate this like this. And now this 6 will multiply by A, 7 will multiply by B. And then 6 multiplied by C and 7 multiplied by D. So you will have to observe this. The first entry will multiply by A, the second entry will multiply by B. So please observe it very carefully that what I am going to do. 6A and there is a sign of plus in between. It is very important to mention this positive sign, because now we are making a single column. 6 multiplied by a plus 7b. Okay, in this way. The same thing we have to do, because this was the column like this. I have rotated it. Now you can see, because there were 2 rows here. Here there are 2 columns. So 2 rows of this matrix are justifying to 2 columns of the first matrix like this. That's why I'm telling you that the columns of the first must be equal to the rows of the second, because there are 2 rows. Here there are 2 columns. Now 6 multiplied by a, I have written this. 6 multiplied by 7 multiplied by b is this. Now the same goes here. 6 c plus 7 b and the bracket close. Okay. Now there is a sign of plus in between. You must remember this. Now you will have to observe the order of the matrix again. You can see that here the order of the matrix was 2 into 2. Oh, sorry. Here it is 7D. 7D. Thank you so much. It is 7D. Okay. And this order is 2 into 1. Now here you can see that the order here, the column of this was equal to the row of the second. Okay. Now what is the order of this matrix? There are rows, 2 rows, and there is 1 column, because this is the sign of addition in between. So this is basically the whole thing is making 1 element, because this is a sign of multiplication. Previously there was no sign in between, there was a gap. Now here it has become 1 column into 1. Now it is very important to observe this. You can see that this is the row of the first matrix and this is the column of the second. So the resulting matrix is having, this is the order of the resulting matrix. Just observe this. This is the order of this resulting matrix, in which the rows of the first and the column of the second are combining like this. In first of all, before multiplication, I told you that the column of the first must be equal to the rows of the second. And when you will get the resultant matrix, then the rows of the first will be equal to the column of the second. Now let us understand with another example. I'm going to give you another example with the numbers on. Okay. Well, let us have another example, like if I have 5, 6, 8, and 9. Suppose these are the numbers. In the same way, if I have another 3 and 4, like this. I'll do some more matrices, inshallah, to make it clear. So please keep on watching. Now you can see that this is the column. I am going to make this like this, 3 and 4. 3 and 4, I'm writing this. Now you can see that this is 3 and this is 4. And I am rotating it like this. 3 multiplied by 5, 4 multiplied by 6, like this. 3 5s are 15 plus 6 4s are 24. In the same way, 8 3s are 24 plus 4 9s are 36. Now you will have to add this. By adding, you'll get 39, and 6 plus 4 is 10, 3 over 5, 6, 60. Okay. So there's no need to use the calculator, because normally from P1 these type of questions are. So you can see that here this is the matrix which has the order 2 into 1, 2 rows and 1 column. Here the order of this matrix was 2 into 2, and here is the order of 2 into 1. So before multiplication we have to check that the rows, the column of the first must be equal to the rows of the second, column of first must be equal to rows of the second. And when you will see the resulting matrix, then these are the row and this is the column. Okay, so the resulting matrix is having like this. Let us understand with the help of another example. Okay, so I am trying to give you another example. Okay, well, so, okay. 4, 5, 6, 7, 8, 9. If I have a matrix like this, now I have another matrix like 1, 2, 3. Now here again, you will have to observe the order of the matrices. Now here you can see the order of this matrix. There are 2 rows and there are 3 columns. 3 columns. So rows and column, first of all, rows, number of rows are 2 and the number of column is 3, 2 into 3. So the order of this first matrix is 2 into 3. Now here in that case, there are 3 rows, 3 into, there is only 1 column, 3 into 1. Now we will have to see that how we are going to multiply. Okay, now you can see that the order of the first matrix is 2 into 2. This is the row and this is the column. This is the row and this is the column. Now you can see that the column of the first matrix is equal to the row of the second. Column of the first is equal to row of the second. So first of all, we have to check this whether they are equal to each other, then we can multiply. Now we are going to multiply with the same rule, whatever we have understood in the first cases. Okay, so here, first of all, before placing this bracket, let me tell you, I am going to make another column with the help of piece of paper because it is very helpful for me to make something like this. 1, 2, 3. 1, then 2, and 3. Now you can see that this column is 1, 2, 3. I am keeping this like this. So it means 1 is multiplied by 4, 2 is multiplied by 5, and 3 is multiplied by 6. In the same way, when I'll go down, 1, 7, 2, 8, and 3, 9. So this I'm doing. Okay. So 4 into 1 plus 2 into 5. Okay. Plus 6 into 3. Here you can see that this was vertically and I kept this horizontal. Here there were 3 rows. Here there are 3 columns. That is why the rows must be equal to column. Okay. Now you can see that 7 into 1 plus 8 into 2 plus 9 into 3. Now closing the bracket like this. Okay. Now you can see that this was the column and then I kept it like this and I multiplied each and every respective rows. Mean the 1 will multiply by 4, 2 will multiply by 5, and 3 will multiply by 6. The same goes for the lower row also. So here I am writing the resulting matrix like this. 4 ones are 4, plus 5 twos are 10, plus 6 threes are 18, 7 ones are 7, plus 8 twos are 16, and 9 threes are 27. Now adding all these, 10 plus 18 gives you 28, and 28 plus 4 is 32. 32 plus 8 is 36. 36 plus 8 is 42. 42 plus 8 is 48. 48 plus 4 is 52. 52 plus 4 is 56. 56 plus 4 is 57. 57 plus 4 is 58. 58 plus 4 is 59. 59 plus 4 is 60. 60 plus 4 is 65. 65 plus 4 is 70. 70 plus 4 is 80. 80 plus 4 is 90. 90 plus 4 is 100. 100 plus 4 is 200. 200 plus 4 is 300. 300 plus 4 is 450. 450 plus 4 is 500. 500 plus 4 is 600. 600 plus 4 is 700. 700 plus 4 is 800. 800 plus 4 is 900. 900 plus 4 is 1,000. 1,000 plus 4 is 2,000. 2,000 plus 4 is 3,000. 3,000 plus 4 is 4,000. 4,000 plus 4 is 5,000. 5,000 plus 4 is 6,000. 6,000 plus 4 is 7 Very good. 32. And then we are going to add, what is the result of these three? 50. Okay. The result of these three is 50. Now you can observe that its order is, there are two rows and one column, two rows and one column. So two rows and one column. You can see that the resulting matrix has the order like this, rows and column. In this way, you can confirm that whether you are doing correctly or not. Okay. So negative sign, suppose minus is written outside like this. And this is 5 minus 8 minus 7 and 3 like this. So I'm telling you that is, as I told you earlier, then that in the matrix multiplication, if this negative sign is out of the bracket, then this negative sign mean this is minus 1 basically. Okay. Obviously, if the a lone negative sign doesn't has meaning, it mean it is negative one, so this negative one will be multiplied within the bracket. So first of all, if there is a negative sign out of the bracket, so it mean there is negative one, so first of all you must multiply with minus all the entries, so it will become minus 5 and plus 8 plus 7 and it is minus 3. So this is called the negative of a vector. So first of all, before multiplication, if there is a situation like this, so first of all, you must multiply within the bracket and the respective signs of each and every element of the bracket within the bracket will be changed. Okay. I hope that you have understood. I'll give you more examples.